This is a video from section 3.1. Recall, number 1, if n is any real number, the derivative of x to the n with respect to x is equal to nx to the n minus 1. So this is the general power rule. Okay. Number 2, the derivative of a constant with respect to x, so c is constant, the derivative of that constant is equal to 0. Number 3, if f is a differentiable function and c is constant, then the derivative of c times f of x with respect to x is equal to c times the derivative of f of x with respect to x. So in other words, we can pull that c out in front and just take the derivative of f of x with respect to x. And then on number 4, if f and g are differentiable functions, then the derivative of f of x plus g of x with respect to x is equal to the derivative of f of x with respect to x plus the derivative of g of x with respect to x. And the derivative of f of x minus g of x is equal to the derivative of f of x with respect to x minus the derivative of g of x with respect to x. So on both sides, we're differentiating with respect to x. Now, we're going to take a look at number 28. And this is in the Stewart Calculus textbook, 9th edition. So suppose k of r. So it's just the name of a function. R is the variable, right? This is equal to e to the r plus r to the e. Okay. Now, one more thing I'd like to recall, and we'll put this off to the side, is that the derivative with respect to x of e to the x is equal to e to the x. So with that in mind, I'm going to take k prime of r. Now, we're going to take the derivative of the first term, and we're going to add it to the derivative of the second term. The derivative of the first term, and in context, this is with respect to r, it's going to be e to the r. Now, in the second term, remember, my n is equal to e. So I'm going to pull the e out in front, and I'm going to multiply by r raised to the e minus 1. So you want to remember, in the second term, e is constant. E is approximately 2.71828, etc. So this is how you find the derivative of k of r. If we take a look at number 30, g of q is 1 plus q to the negative 1 raised to the second. So here's a good example where you're taking something to the second power. If it looks like you need to square it, chances are you need to square it. Okay? So this is 1 plus q to the negative 1 times 1 plus q to the negative 1. And we're going to multiply that out first before we take the derivative. So we get 1 times 1 is 1, plus 2q to the negative 1 plus q to the negative 2. Okay? Now, let's go ahead and take its derivative. So we want g prime of q. The derivative of a constant is 0. So the derivative of 1 is 0. So I'm going to write a 0 there. And I'm going to carry the 2 along for the ride, and I'm going to take the derivative of q to the negative 1. But that's negative 1 q to the negative 2. And then I'm going to go plus negative 2 q to the negative 2 minus 1, which is negative 3. And the way I want to teach derivatives is as much as possible, we want to get a common denominator. It's going to help us later on when we get to chapter 4. So g prime of q is negative 2 over q squared. We could write it this way. And then we're going to subtract 2 over q cubed. So we're going to say the LCD is q cubed. So this is negative 2q divided by q to the third minus 2 over q to the third. And so therefore, g prime of q is negative 2q minus 2 over q to the third. And this is a really, really nice way to express the derivative of g of q. And that's how you do problem number 30. Let's take a look at problem 34. 34 is very interesting. So we get y equals e to the x plus 1 plus 1. Now, I want to take the derivative, but I don't know what to do with x plus 1, right? So we want to recall a couple of things. Now, don't forget that the derivative of e to the x is equal to e to the x. And the derivative of any constant is equal to 0. So we're going to need both of those. And one more thing I want to recall is that a to the m plus n is a to the m times a to the n. And that's going to allow us to rewrite this as e to the x times e to the first plus 1. So when I want the derivative, and I'll call it y prime, e is constant, right? So I could just write that down. And I'm going to take the derivative of e to the x. But the derivative of e to the x is just e to the x. So I'm going to write this as e times e to the x. The derivative of any constant is 0. So I'm going to add 0. And so therefore y prime is equal to e to the x plus 1. And that's not a coincidence, by the way. And so one thing I'd like to note down here is that if I take the derivative of e to the x plus some constant k, you're going to get e to the x plus that very constant. And so remember here, k is constant. And you're going to find that that will happen every time. Okay? And that's problem 34. Now, suppose I said the following. Find an equation of the tangent line to the curve at the given point. And so I'm going to take a look at problem 37. Now, suppose I have the following. Y equals 2x cubed minus x squared plus 2. And the ordered pair is 1, 3. Okay? Now, I want to draw a picture of what it is we're exactly looking for. Here's x, here's y. Okay? I'm going to go over 1 up 3. And now, suppose I had a function. I'm not saying this is what it's going to look like, but suppose it's doing something like this. Okay? For sake of argument, we'll say. Now, here's what we have. We have the ordered pair 1, 3, and I'm going to use blue. Now, we're going to draw a line that's tangent to the curve at that point. Okay? Tangent, essentially, it touches at that point. Now, we're going to need to find the slope of that line. And that's where the derivative is going to come in handy. And so we're going to take the derivative of this function with respect to x. And then we're going to plug in x equal 1 to calculate the slope of the line at that point. Once we know the slope and we have the point, that's going to allow us to get the equation of the line. Okay, so now let's go through this. So we have y equals 2x to the third minus x squared plus 2. Okay? Now, I want to take the derivative. Now, remember, 2 is constant, so that's going to go along for the ride. And I'm going to take the derivative of x cubed. But the derivative of x cubed is 3x squared. And the derivative of x squared is 2x. And so I'm going to subtract 2x. And so here I get 6x squared minus 2x. Now, let me spell at here. X equal 1, y prime is equal to 6 times 1 to the second minus 2 times 1. Because remember, we're trying to get the slope of the line. Well, that's 4. So this is the slope of that very line that I drew in blue. That's the line we're looking for, the equation of that line. Okay. Now, so we're given slope 4 and point 1, 3. Now, let's see if we can put that together. So we're given y equals mx plus b. Now, m equals 4 when x is 1, y is 3. Okay? That's what that means. And so we want to use that information to solve for b. And then we're in business. And so I'm going to replace y with 3. I'm going to replace m with 4. I'm going to replace x with 1, and then I'm going to add b. Solving for b, I get b equal negative 1. And so that implies y equals 4x minus 1. And that's how we found the equation of that line. Let's do problem 38. Suppose y equals 2e to the x plus x, and the point is 0, 2. Same idea, we're trying to find the equation of the tangent line. And so y prime is 2 times the derivative of e to the x is e to the x. The derivative of x is just 1. So I'm going to add 1. Okay. Now, I'm going to plug in x equals 0. That's the first coordinate of that ordered pair. We're going to get y prime is 2 times e to the 0 plus 1. E to the 0 is 1. 1 times 2 is 2. 2 plus 1 is 3. So we're given slope 3 and point 0.02. But remember, this already gives me b because it's a y-intercept. And so therefore, the equation of the tangent line will be y equals 3x plus 2. So again, this is the tangent line that we were looking for. That's how you do 38. Let's take a look at 39. We'll make this the last one for this video. Suppose y equals x plus 2 over x, but this is x plus 2x to the negative 1, like so. So if I want y prime, this is going to be 1 plus 2 times negative 1 x to the negative 1 minus 1, which is negative 2, which is 1 minus 2x to the negative 2. Now, the ordered pair, by the way, here is 2, 3. So notice when x is 2, y is 3. So I'm going to go ahead and plug in x equal 2 because I need that slope. So at x equal 2, y prime is 1 minus 2 times 2 to the negative 2, which is equal to 1 minus 2 over 4, which is a half, by the way. So we're given slope 1/2 and point 2,3. So remember y equals mx plus b. The slope is a half. My x value is 2, so I'm going to multiply by 2. I don't know b, but I do know my y value is 3. So 3 equals 1 plus b, and that says b equals 2. And so therefore, y equals 2, well, actually the slope is a half, right? So it'll be 1/2 x plus 2. And in the next video, I'm going to show you how to find not only the equation of a tangent line, I'm going to teach you how to find the equation of a normal line. And that'll conclude this video for section 3.1. We did some examples of calculating the derivative, and then we also did examples on how to find the equation of a tangent line. Okay, thank you.